All right, so you have this graph right here and stuff. And if you don't have this to where you can print it, just quickly sketch it into your notebook. Take the time to do it real quick. I'm not worried so much about it being exact, but just kind of do a quick sketch through. And what we're gonna do is we're gonna discuss this, all right? The first thing that you always need to do is you need to look at your title and your XY axis. So we have distance versus time. I have distance, says it's going in meters, and I have times, I'm looking at it in seconds. Now, this graph right here actually tells me a lot of different things, and this is kind of going over our walking lab. It's going back and it's redoing all of those graphs for us in one graph right here, and then we're going to answer some questions when we're done. But I want to kind of discuss this, all right? So the first thing I want you to do after you sketch this in, I want to talk about from 0 to 1 second, because I know this line between is going to give me a 1 second. So what happened to my distance when I started from A to B? Well, if you look at it, it goes like this. It's going upward. So obviously my distance isn't 0 anymore. It went up to 30. So my distance increased. So I got farther away from the starting point. So if my distance increased, then I know what I did was I started moving forward. To get to my place. Well, then at 1 second, I kind of just was like, uh-oh. I go from 30 down to 10. So I have to stop and think. Over the next 3 seconds, something happened. I didn't slow down. When I'm looking at it, my distance went down. So what happened was I went and I turned around. Because my distance was at 30, and then I figured out I had to go back to 10 meters. Maybe I dropped my phone. I don't know. Maybe I realized I lost my key. Something happened to where I had to go back to the 10 meter step and stop. All right. So I turned around and I started declining and going down. So my distance decreased. Now what's important is, if this word would have said speed, my speed decreased, but this one says distance. So I didn't slow down, I literally turned around because my distance went down. So make sure you really focus on your X and Y axis, because your Y axis is gonna have different things over there labeling it, and it's gonna give you completely different information. So I turned around, and then at 4 seconds I said, maybe I started filling my pockets and I found my keys or I found my phone. But from 4 seconds to 6 seconds, my distance didn't change. So if I had no change, we call that a stop. I just decided to stop because I had no change in distance. All right, so with no distance change, means I'm not moving. Time keeps going on, because if you see my 4 seconds to 6 seconds, it kept going, but I didn't go anywhere. All right. Then all of a sudden at 6 seconds at point D, I decided, well, crumb, I need to get back up to 30. So I started to go forward again. So I moved forward. And the way I know I moved forward is my distance increased. And then at 8 seconds, I went even farther. I kept going for another 2 seconds. So I know that I moved forward here also. The same way I know I moved forward was my distance again increased. All right, so what you're gonna do is you're now gonna answer these 5 questions about this graph real quick. Go ahead and do that. Answer them real quick in this Edpuzzle, and then we'll come back and we'll discuss them a little bit. All right, so you answered your questions in the Edpuzzle. So I have my information up here on this. Let's talk about what we saw. Between which 2 points does the object stop. Where did I stop? Well, if I looked at my graph right, I could see between points C and D, because I wrote that on there. There's no movement. My distance didn't change. All right. Between which points does the object have the greatest speed? Well, that means I went the farther distance. That means I'm going to have a way steeper line, guys. I'm going to have a very steep line. And when I look at it, in 1 second, I went from 0 to 30. Well, I have kids say, well, what about D to, D to F? Well, that's over a long distance. That's 4 seconds that I'm going from 10 to, that's 40 over 10 seconds. That's not going to give me a big gradual change. So this one right here, I'm going to look at, it's A to B. I went fast from A to B. I wanted to get there. All right, describe the motion that happened between A to B to B to C. Well, A to B, we said we moved forward. B to C, my distance went down. When my distance decreased, I turned around. And I'm just going to write, turned around. That's what you saw happen. We literally turned around. Just like on walking on the fourth one for Monday's lesson, or Tuesday's lesson, when we had to do the walking lab. It turned around. All right. Then it says, at what points does the object change direction? Where did it change directions? Well, I changed at B, then I changed my direction again at D. Because didn't I start moving forward again at D? So at B, I turned around, and at D, I started going forward and turned back around. So B and D. And then calculate speed for point E. All right, so I've got to come back here, and I've got to look at my notes. My notes tell me for speed equals distance divided by time. I'm going to write that down there. Speed equals distance over time. So let's think this through. Distance over time. What was my distance? All right, I'm looking at E. I'm just coming over here to read it. My distance was 30 meters. My time it took me 8 seconds. So when I do that math, I'm going to put into my calculator 30 divided by 8. Which is going to give me 4, 6, 0, 7, 56, 40, 3.75. You're sitting there going, whoa, I know. Simple math, kids, simple math. All right, so I went a speed of 3.75 meters per second. Remember, if you do not have your units of measurement, they mean nothing to me. 3.75 doesn't tell me anything. I have to know what my distance and my time was recorded in. All right?